All right. Welcome, everybody. I am remote. I am hoping that the internet holds out for me. I am on a completely different platform. Please give me a shout out in the chat that you are hearing me right now. Um, I'm hoping that you are. Edit channels. I'm just going to double check my channels. It says I am streaming, so please let me know if we've got people out there. So today we are going to be talking about. Yes, I am. Channels. I'm just going to double check. There we go. So I've got good audio. All right. Excellent. Thank you, Yummy Fudge. We're going to be doing some of this today. Showing you some of the comments. So just so you're aware, I'm going to walk down through some of the questions and comments and all that jazz. I am looking forward to wrapping a bow around our services, and we will be taking a look at the 2026 code cycle. As you know, I am traveling, and I didn't record this, so we are live, Yummy Fudge. So we are going to wrap up services, interconnected systems with a view of 2026 NEC, and it all starts now. Greetings, everybody. Robert from Omaha. And I appreciate you as well. We would not have a YouTube channel without all of you out there ready to dial in and engage. The last two meetings were very enlightening. And I'm trying to cancel out of something over here. So I have TerraView up over here. The last three, I mean, this discussion of services, I don't know about you, but the entire discussion around surface equipment services was very enlightening. And I realized during those discussions, we generated some public comments. And we need a Discord as well. A Discord. And Datcord and Discord, all the cords, we need them. Salute. So I'm drinking my coffee from my hotel. All right. So just as a summary, if you recall, we had some diagrams we put together. Let me see if I can do this. We need a Discord as well. How do I? There we go. I'm going to minimize that. I'm going to I got to minimize this. You would not believe my setup here. If you saw this setup. Hey, Michael Hofkin in the house. If you would see what I've got going on here, I have got a tripod that is balanced off of the HVAC system, which does not look very good. Excellent. Let me bring this back up so I can. There we go. Michael Hofkin in the house. Greetings and salutations. There you go, and I'm going to be able to show this. Thanks for the effort going live while traveling. Thank you, Laurel, for dialing in. All right, so if you recall, and I started my Amanas. So let's do this. Let me see if this works. Look at that. Does that work? Yes, it does. Remember these diagrams. Oh my goodness, look at all these diagrams that we went through. We talked about the power distribution block. So what I want to do today is I want to take a look at some of these requirements and or some of these applications, and I want to take a look at the 2026 code cycle. So I am going to open up Article 230. There are a few things that, you know what, Robert, you are funny. Robert thinks that I'm the Johnny Carson Live. Oh, man. All right, so Robert and Michael and Yummy Fudge and Laurel from Omaha. All right, so I am going to take a look at Article 230 because there were some first draft changes made in Article 230, and I can talk about some of the public comments as well that we are addressing, and that is Code Making Panel 10. So the first change is in Article 230 Section 230.2. All service equipment shall be listed or field evaluated. We just had a task group on this. And I'm telling you, this is really interesting. Really, really interesting because, can I call up the language that they're considering? I believe it was Robert Osborne put this public comment in. And he's saying that he says the following equipment shall be listed or field evaluated. Michael, I'm gonna love to hear your comments on this one because we had a big debate on why field evaluated is in 230 now 230.2. It was a requirement in for service equipment last cycle too. So if you look at the listing requirements in Article 230 for the 2023 code, it said that service equipment shall be listed or field evaluated. Now, the discussion that we had was why would we put field evaluated there when we don't put it anywhere else? So our discussion was such that if we put field evaluated in, does that mean that when we say elsewhere that it shall be listed, that you can't do a field evaluation? Where's the permissions in the National Electrical Code that you can do a field evaluation? So I'll tell you what, we had a really good debate on this. Now the list that Robert put in his public input said, and I'm going to see if I can do this. David Engelhart is in the house, and he says, "Greetings all." He's going to go out on a limb and presume you are at the Northwestern Section meeting. And if you had presumed that, you would presume el wrongo. I am not at the Northwestern Section meeting. I have a different meeting. I am in Vermont right now. Am I in Vermont? I am in Vermont for the United States National Committee meetings. This is on the International Codes and Standards front. I am on the Technical Maintenance Committee, and we meet tomorrow. I came out a day early because traveling today would have been impossible because I have meetings all day today outside of the USNC meetings. So I am in Vermont. So anybody out there who's in Vermont, I am in your backyard. You should be very afraid. All right. Limb broke. Boom. Absolutely. Okay. So what Robert put in here is he says the following equipment shall be listed or field evaluated, and he has all service equipment, meter sockets, power distribution blocks, pressure connectors, devices for splices and taps. So I'll tell you where we went with this. We said, look, if it's a pressure connector, if it's a power distribution block, if it's a device for splices and taps, it's going to be listed, not field evaluated. Because these are components. And if you took a component and let's say that you did something to the component, let's say you took a power distribution block and you modified it for whatever reason that would cause an electrical inspector to say, look, I need a field evaluation done on that power distribution block, you're probably into the discussion of reconditioning, because there's not much you can do to a power distribution block. There's a lot you can do to service panel boards, enclosures for service panel boards, where a field evaluation may be warranted. So we're in the process of debating this in a task group. And what we're leaning back on is we're saying that power distribution blocks, meter sockets, pressure connectors, and devices for splices and taps are required to be listed. VT is the upside down New Hampshire. I know, and you know what? We ate dinner in New Hampshire last night, which was delicious. So this was the language, and I'll tell you what we ended up doing here. Was we said that this product. So item 3, item 4, item 5, and 2, all 3 of these have to be listed. Period. Okay? But that product up there shall be listed or field evaluated. So that's, I believe, where we're going with this. But the section for that previously, basically all it said was all service equipment shall be listed or field evaluated. We can't just lump it all into one, because there are listing requirements and no field evaluations, and there are equipment that can be field evaluated. So that is sort of where we ended up in our discussion. Now, Yummy Fudge says, the Yum Fudge Master says, in my opinion, field evaluation is by UL or a similar body, separate from a is allowed at the AHJ, providing permission. So, yeah, so you could have UL, Intertech, and in fact, you know what we call those for a field evaluation? Field evaluation bodies, FEBs. So there is a defined term for an FEB in Chapter 1, Article 100, and let's see if that's changing. Field evaluation bodies, and Mr. Hofkin fits that mold in his organization. A field evaluation body is an organization or part of an organization that performs field evaluations of electrical or other equipment. And I don't need to be a nerdle like a UL or an ETL or a TUV round. I could be an electrical contractor and be a field evaluation body. So an FEB. There is a standard, NFPA 790 gives us the guidelines for establishing the qualifications and competencies thereof. Okay? Tom, could it have something to do with the refurbishing equipment such as switchgear? So, Michael, so this is our. I think this is. I believe you are spot on. When I look at 230 and I look at the listing requirements, we had this discussion that it could be that you have something that was prepared for a utility that's not listed. You have it installed. Now, what do? You could do a field evaluation. If you modify the service equipment, I may need to do a field evaluation, right? And remember, a modification could be something as simple, Michael, as changing the label. Let's say, for example, for some reason, the label on the inside door of the service equipment needs to be modified, and I need to put a new label on there. I just can't do that. I would need to get a field evaluation to get that done. Maybe it was labeled incorrectly, or maybe something, I don't know. I'm making stuff up. But there may be a reason why you need to modify that product in the field, and then you would get a field evaluation. If we said it shall be listed, which this is my problem, Michael. This is my problem. There are a lot of other places where we say it shall be listed. Does that mean that you can't modify, say, make a modification in the field where the inspector says, I need a field evaluation because now you violated the listing mark? We do that every day on a lot of different solutions. So why do I need to put it here in service equipment? That's what I don't understand. My gut was telling me just take it out. Why do we need or field evaluate it? Because we know field evaluations is a part of our hierarchy or our fabric in our industry. But nowhere in the code does it say, or does it? I think we only use field evaluation body a couple times. If I go to NFPA link, let's go. And who out there, do you guys all have NFPA link? I'm hoping that you do. Contractor can be. Yes, I didn't know that changes how I think about it. Yeah, Yummy Fudge. There's nothing, because I didn't know that either. And the reason I say that is because I was speaking with an electrical contractor up in Portland or Washington State or wherever it was. And I made the statement in a presentation. I said, well, only a nationally recognized testing laboratory like UL, ETL, TUV, etc. And I had a guy raise his hand. He goes, that is incorrect. He says, I am a field evaluation body and I'm an electrical contractor. So that was. So Laurel says, in many cases, isn't the FEB cost prohibitive? And I would say, no, Laurel. You have to weigh what are the differences. If I say I popped a hole inside of a panel board service equipment, and the inspector says you just compromised the listing of that product, he wants it, or she wants a field evaluation. If that's $1,500, that panel board or that switchgear could cost you thousands. So I think it's a misconception that field evaluations are cost prohibitive. I have seen too many of them where we went into it saying, well, we're going to call this Nerdle, and it would happen to be UL in both of or a few of the cases, most of the cases that I was involved with. And they said, well, this is never going to happen because it was way too expensive. And it turned out being very reasonable. So I would say, don't count your chickens till they hatch. There are only a few places that it's used. That's correct. So if I go field evaluation in in NFPA link, field evaluation, I'm going to search for that. So you have Article 100, field evaluation body, 690 for photovoltaic, 690.4b, approved. The definition of approved. I don't think it's changed, but I am going to take a look at the definition of approved. In NFPA 70, which I should not have clicked on. I am probably compromising my internet connection. Approved. Approved says acceptable to the authority having jurisdiction. Oh, I know what. Field evaluation body is probably in the enhanced content. When you search, in NFPA link, you've got to be careful because it will find where that term is used in the enhanced content, and that's not enforceable language. So you've got to be careful there. And it'll highlight in the search. Look, let me show you. Whoop. Let me show you something. All right, I go to teach. There we go. So you look here, I did a search in NFPA link, and you'll notice it says it found it in 694.7, but look, it highlighted enhanced content. So it found field evaluation body in there, but it was not in the, now here it is in 705.11, that's field evaluated for the application and field labeled. That's enhanced content, enhanced content. There's your FEB or Article 100. So, whoa, it looks like, oh wait, there it is. I got to move this. How do I move this? There we go. Whoa. Boy. So 230.66, all service equipment shall be listed or field evaluated. That's what we're looking at right now. So that was in 236.66. We moved that up. And somebody asked the question, why does it say field evaluated? What does that mean? Does that mean that I don't have to have listed product, that I can just say, hey, I put a box together, I put some breakers in there, and boom, she's done. I speckled in some safety, and I called Michael Hofkin, and I slipped him the directions to the job site, and he showed up and said, yep, looks good. Field labeled as applied to evaluated products. So we're evaluated. That's F. Okay, let's look at that. I'm going to try that. I'm going to come back to this. And while I'm doing that, let's take a look at some more comments. Michael Hofkin says, some engineering firms are field evaluation bottles. Yeah, you know what, Michael? I did not know that was even possible. I don't know when that was that I had that. It came over. I was enlightened, but I know it was at an IAEI meeting that I learned that. How about, so Robert says, so as an EC, electrical contractor, and the field evaluation body means I have to be recognized by an AHJ, leave a label that I was there, provide a report, etc. Yeah, yes. And so here's what you're getting to, Robert, is do we have the language in Article 1, in somewhere in the code that says when you do a failed evaluation, what does that mean? And I'm not finding something to my satisfaction along those lines. Field evaluation, all of NFPA 70, and now I lost my MTV. All right. So David says, my boss required a field evaluation for lake fountain control panels that were put together with the guts of a 612 panel board, and one half of the breakers were on in the down position. Yeah. When you don't have listed product, that's the challenge. When you don't have listed product, it makes your life, David Engelhardt and others who have to approve something like that, very difficult. But when it doesn't smell right, if it's not listed and it doesn't smell right, you can always ask for that. But so we struggled with I'm going to get back to Tara. We struggled with the 230.2 language. Robert Osborne from UL made a public comment, and we had a correlating committee note, which I can't see what the correlating committee note said. So in any case, that's the listing. So be careful when you get to, and here's the other issue. Think about the hazard. All right. So think about the hazard. Think about the severity. We are managing severity through thanks, Yummy Fudge. I appreciate that because I'm sitting here in my mind thinking, are we going down the right road? But in any case, you got to think about the severity around what we're dealing with. So a listing of all of that equipment is critical, and I think it's very important. I'm not going to say critical. I'm going to say it's very important because as an electrical inspector or as a design engineer or electrical contractor, as a design engineer, I have my PE license. If I'm going to sign off on something, I have to make sure it's going to do what it says, what I say it's got to do. As an inspector, you're going to sign off on it saying, hey, everything looks good. It smells good. It looks good. Tastes good. Have you licked your panel boards recently? I mean, a chocolate flavor to them. But we have to approve them, and we have to base it on something. And if we don't have that expertise around the standards and around the design of that product, then you need that third-party review. So the code is saying, look, service equipment is going to be listed. But they threw in the field evaluation, and I don't know. We had the discussion, does that cause confusion? All right, so moving onward and upward. I am surprised that I'm able to do this because you have no idea how poor my internet is here. It is very poor. Okay, so I'm moving forward. We are changing some references to article where we were pointing to Article 220. We're now pointing to Article 120. So good to go. We added some clarity in 230.23, size and ampacity. We added some clarity in the exception for B, minimum size. Remember, in the minimum size, it tells us that the conductors shall not be smaller than a number 8 or a number 6, aluminum or copper clad aluminum. And gotta cross my leg. And it says, what we said was in the exception, it said conductors supplying only a single branch circuit. We said service conductors supplying only, and we removed limited loads of, only a single branch circuit. Shall not be smaller than a 12. And we removed such as small polyphase power controlled water heaters and similar loads. So I guess that would be a single branch circuit. So that would mean if you have service equipment, if you put a panel board in and you have only one breaker in there. Exception, service conductor supplying only a single branch circuit shall not be smaller than a number 12 hard drawn copper or equivalent. We don't really say whether or not you can add in the future. So if I put a panel board, I have one breaker in it. Do I meet that exception? I would, as it's built, because we're inspectors, not expectors, but I could always add breakers later and supply more branch circuits. It doesn't say it shall only be able to. Take a look at 230.23b, minimum size. That's, let me look at the public inputs. Oops. Ryan Jackson put this one in. The exception is far more complex than it needs to be. He says there's no reason to explain what a single branch circuit is, which we do. In that exception, we explain. We say conductors supplying only limited loads of a single branch circuit, and it has such as small polyphase power, controlled water heaters, and similar loads shall not be smaller than. And he says he thinks that it's understood well enough that the conductor size doesn't change by being hard drawn or soft drawn, because we have that stinger. So he wants that out. It says 12 hard drawn copper. So that language should be removed. And then it says, and what is the equivalent? If this is referring to copper versus aluminum or copper clad, that's issues addressed in 110.5. So he suggested the language change. We didn't do exactly what he said. We left in the hard drawn copper, but we basically, it says service conductor supplying only a single branch circuit shall not be smaller than 12 American wire gauge hard drawn copper or equivalent. And then we said the language is revised for clarity. Examples of single branch circuits are unnecessary. The removal of hard drawn copper was not made due to the lack of substantiation. It is unclear if that would have negative impact. So we made that change. And Nihad says, so hold on, Nihad says, hey, didn't know that he was live. Thanks for joining. It's Tuesday, Nihad. Tuesday at 12. We go live. Okay. 230.24 clearances. Overhead service conductors shall not be readily accessible and shall comply with 230.24A through E. And there was language in there that says for services not over 1,000 volts. So here's another big change. We moved above 1,000 volts to different articles. So the scope of Article 230 does not include medium voltage. 230, we moved it to where did we move it? Branch circuits, feeders, outside branch services, 268. So we moved the medium voltage service requirements to Article 268. So if you're wondering what happened, that's where it went. Remember, we had a 235, I think it was, and we had part one was branch circuits, or I think part one was services, part two was feeders, and part three was branch circuits, or it could have been reversed: branch circuits, feeders, and services. Part one's general, part 2, 3, and 4. So they split that out into different articles. So we have what we have is branch circuits that are over 1,000 volts AC are in 265, new Article 265. Feeders is in Article 266. Outside branch circuits and feeders is in 267. And services is in 268. Ocho. All right? And then grounding bonding of systems over 1,000 volts is in 270. And Yummy Fudge says, I think it's overly complicated as well. Yes, it is. That, in any case, so that was 230. So let's look. That was 230. Take a look at 230.23. You're going to want to look at that. Nihad says, I know, I forgot because I didn't know what time it is. He's in. Oh, you're in the air. You're in the air. Look at this. We are international. And we are, what would you call that? If you're in the air, and you're in the air flying to Vancouver from Frankfurt, Germany. Man, Nihad. All right. let's keep this rolling. Let's keep this book going. All right, so 230.24, we already talked about the services, the clearances. We made a change in the parent text of 230.24, and in B, around the 1,000-volt thing, remove that reference because the scope of 230 now is limited. 230.31, size and ampacity, we point to Article 120 instead of 220. Easy changes. Easy peasy. So 230.42, minimum size and ampacity. Airborne, yes. Vince B. In space, from space. Oh, man. In space or from space. That's the truth. Okay, so minimum size and ampacity. So this one says, okay, all right, so this is a good discussion here. Conductor ampacity. If you are anybody who wants to learn about conductor ampacity, you're going to want to come to the Western Section meeting next week, because at the Western Section meeting, Ryan Jackson is going to do a conductor ampacity educational program. And from what I understand, it is knock your socks off informative, and it simplifies ampacity, because I don't know about you, but it leaves a lot to be desired. If you look at 215 for feeders, 210 for branch circuits, and now in 230.42, we talk about the minimum size and ampacity. So in A, now remember how this is laid out. A gives you sort of the recipe. And it says you have to take the larger of these two calculations. The first one is continuous and non-continuous loads. So that's the 1.25. And you do that evaluation and you come up with what size conductor there. And then the second one, you apply the adjustment correction factors, which that's your conditions of use, but you don't do the 1.25. But then you have to keep an eye on 110.14c, which is your terminations, because that could be the limiting factor. So, oh man. So what we said was the clarity that's added in 230.42, it says service entrance conductors shall have an ampacity of not less than the maximum load to be served. Okay? So the ampacity of the service entrance conductors cannot be less than the maximum load to be served. So that is an entry point. So you have to do your load calculation and calculate that and make sure that the ampacity of the conductor, the service conductors, is not smaller than that number. It says conductors shall be sized not less than the larger conductor of A1 or A2. And this is A1 is the 1.25 multiplier, but not the conditions of use. And A2 is your conditions of use, but not the 1.25 for continuous loads. All right? So in A, we added clarity. We said not less than the larger conductor of 230.42A1. And I'm not sure I agree with that change. Maybe I do. And the reason I say I'm not sure if I agree with the change is because all I'm determining here is I just need to know what is the ampacity that I need. Then I go back and I pick my conductors. Or do I? No, I guess I'm okay with that because I need to know my insulation. So here's my thought process. What I'm thinking is I've got to know what insulation, etc. But I can't do the second calculation for conditions of use unless I know that. Okay, so I'm good with it. So the largest conductor of A2. Then it says loads shall be determined in accordance with Article 120. We changed it from 2 220, Part 3, 4, or 5, as applicable. Ampacity shall be determined in accordance with 310.14 and comply with 110.14c. And then it says the maximum current of busway shall be that value for which the busway has been listed or labeled. And then in the continuous and non-continuous, so item 230.42A1, we changed the exception number 2. And all we did was move things around, because it used to say the sum of the non-continuous load, the sum of the non-continuous load and the continuous load if the service entrance conductors terminate in an overcurrent device where both the overcurrent device and its assembly are listed for operation 100%. So that's 100% rated. And remember, it's not just the overcurrent device that needs to be 100% rated. The assembly needs to be 100% rated too, because in a lot of cases we rely on high density copper bus. You're never going to get 100% rated equipment that has an aluminum bus, period. So the equipment, the enclosure, and the overcurrent device married together. It's not just one or the other. The conductor shall, so what we said was that we just reworded that. The conductor shall be permitted to be sized at 100% of the sum of the continuous and non-continuous load if they terminate to an overcurrent device where both the overcurrent device and its assembly are listed for operation at 100% of their rating. So we just rephrased it, didn't change the requirement. Let's keep moving. Let's take a look at some comments. I'm watching you guys from up above. You're the man, Nihad, Yummy Fudge. He's a smart dude. And then we've got, who's this? Jimmy Tyler, ex-West by God, Virginia, Parkersburg. Thanks for joining in. And Brady. It's Brady from Parkersburg, West by God, Virginia. Thanks for joining in. And looking forward to seeing everybody at our next West Virginia chapter meeting. All right, let's continue to this discussion. So we get into 230.43 wiring methods. Very minor changes there. Oh, yeah, we just removed some, so very minor changes, nothing big. Spliced, this is a big change. So spliced and tapped conductors. So what we did here, we recognized that the debate is whether or not when you splice and tap on the line side, so you remember the discussion around the power distribution blocks. And the other devices that are ahead of the service equipment. There's a concern about that application just because there's no overcurrent protective device ahead of it. It's in line with the service conductors, and we want to make sure that they're listed, identified, and labeled for that application. Well, the problem was that the other types of connectors, because remember, we expanded it to pressure connectors and other devices for splicing and tapping. Power distribution blocks are relatively easy. I'll give you sort of how this went. So power distribution block is listed to a standard. They're tested, blah, 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 blah. There was a public input made maybe 2 cycles ago. I can't remember. That power distribution, 2 cycles ago. Yeah, it was the 2020 code. Power distribution blocks had to be listed for the use when they are on the line side of the service disconnecting means. Well, then somebody asked the question and said, well, why aren't the other methods required to be identified and listed for the purpose on the line side of the service disconnect? It's not just the power distribution block. The argument against expanding 23046 concerns to these others was that the power distribution block is mounted and fixed in place, and the others are not. They are, dust in the wind. So there was some testing conducted and some videos presented that raised the concern that even those that are not fixed mounted should be reviewed for short circuit through currents. So we said there was an future enforcement date because the standards would have to change and those products would have to get listed. The concern was they don't test pressure connectors and these other devices for splices and taps for short circuit currents through faults. So they created a list item of the items, and they added an informational note that says the marking SVC, which, from what I understand, is like a utility industry thing. They don't test those products for a short circuit current rating. But a marking SVC is an industry identification that is considered equivalent to suitable for use on the line side of the service equipment. There were some people that were upset with that because there's no short circuit tests, actual short circuit tests conducted on those. So there are public comments made to 23046. And I'll tell you where they're at. So Robert Osborne submitted something, so did Kevin Arnold, and so did the Correlating Committee. What did the Correlating Committee say? Listing requirement. Listing requirements will be located. Oh, they just wanted to move the listing requirements up. Robert Osborne from UL said shall be marked, not shall be listed and be marked, and it just says shall be marked or identified as suitable for use. And Kevin Arnold is saying and have a listed short circuit current rating greater than or equal to the available fault current. So that will be an interesting debate during our second draft meetings. All right, so that's a change to keep your eyes on. And I'll tell you what the other thing, in 234.46 is on the line side of the service disconnecting means, but we don't have it in section 230.82. Yes, 82. We don't have anything in 230.82 that says it's permitted to be on the line side of the service disconnect. So I made a public comment to add that into 230.82. So we'll see how that goes during the second draft phase. All right, so we were at 230.46. Moving on. Let's take a look. What have we got here? Robert says, you make a comparison of 1 and 2 and take the larger of the two. That is correct, Robert. That is correct. But here's the question. When you do the voodoo that you do so well. So here's the thing. Let's talk about this because it just recently popped up. It just recently popped up. So let me see if I can get this to work. All right. So ampacity. Okay. What 230 and 215 and 210 does says first, you do a comparison calc. A, the 1.25 for continuous. B, conditions of use. And then you take the largest. Right? So that's the first thing you do. Second, terminations, 110.14. Terminations. We have to make sure that, for example, if we did our, based on the conditions of use off of, say, 90 degrees C column, because the conductor insulation rating permits that, if I use the 90 degrees C column for that calculation, I have to make sure that I do not exceed the weakest link. Right? So I can't exceed the weakest. If I'm terminating on 60 degrees C or 75 degrees C, I can't exceed the ampacity for that termination. So that's the second thing. And then the third thing is I can't exceed 80% of the OCPD rating if not 100% rated. Right? So those are three important aspects that I can't lose sight of. It's not just that one calculation. You've got to consider the other aspects. Make sense? So that's something I think, and that's what makes ampacity, the ampacity calculations challenging, is there's so many different little aspects of it. Then once you figured your ampacity, then you have to protect the conductor at the ampacity, and then you go back to selecting the correct overcurrent device. Oh, 705. It doesn't look like a chance to get to this article said there where there's some fault conditions. Well, tell me some of your fault conditions, Yummy Fudge. What time is it? Oh my gosh. Okay, let's talk about 705. I'm just looking. Surge protections getting some changes. They added areas designed for use exclusively for sleeping quarters and fire stations. Service disconnect, readily accessible. We're requiring the service disconnect on the outside of the house now. So we deleted the emergency disconnect section because we're requiring the service disconnect for 1 and 2 family dwellings to be outside of the house. And so then we had to modify the marking requirements for the service disconnecting service disconnect, because it will be your emergency disconnect as well. We made some changes in the 2 to 6 service disconnect and all that jazz, but that's okay. Yummy Fudge. Let's go to 705. I'm sorry, buddy. I got carried away. I could do this. Get some music. All right, 705. Chapter 7, 705 interconnected systems. So, Mr. Fudge, I presume. So I'm looking at the suggested language changes. I'm not sure if you have. Okay, so here's the changes in 705. Let's take a look. 705.1, nothing. Listing requirements, all we did was we changed the title of 705.2. Instead of equipment approval, it's now listing requirements. All that interconnected system has to be listed. There's 705.10, identification of power sources. Permanent plaques, labels, or directories shall be installed at each service equipment location or at an approved readily visible location in accordance with the following. Denote the location of each power source disconnecting means for the building or structure. And there's an exception. Installations with multiple co-located power production sources shall be permitted to be identified as groups, period. We removed the plaque, the plaque, label, or directory. We just said as groups. And it says plaques, labels, or directories shall not be required. So it didn't change the intent at all. We removed a reference to 110.21b. There's some people questioning on the value of 110.21b. So let us know what your thoughts are there. In 705.11, so remember 705.11 is line side of the service disconnecting means. These are service conductors. They made some changes. Service conductors connected to power sources. Service conductors connected to power sources shall comply with the following. The ampacity of service conductors connected to the power source service disconnecting means shall not be less than that of the power production source maximum circuit current in accordance with 705.28a. 2 is service conductors connected to the power source service disconnecting means shall be sized in accordance with 705.28 and not smaller than a 6 or a 4. The ampacity, and number 3 is the ampacity of service conductors to which power sources service conductors are connected shall not be less than that required in 705.11b1 or b2, which we just read. They got rid of connections, splices, or taps, and their justification, I think, was because they said the language has been removed as the requirements of Chapter 2 are still applicable unless it's modified. So they removed a bunch saying, hey, look, it's already in Chapter 2. We don't need to talk about splices or taps or connections because all of that is up there. They removed the bonding and grounding, the service disconnecting means, all that jazz. Overcurrent protection they modified. This is a big one. Condition is if the power goes out from the grid. How do we solve for the grounding conductor on circuit where branch, I'm looking at Yummy Fudge's comment. Condition is if the power goes out from the grid. So if the power goes out from the grid, let's talk about that real quick. Utility interactive inverters shut down. Well, look at that. I got the thumbs up. Watch this. All right. So if the power goes out from the grid, a utility interactive shuts down. How do we solve for the grounding conductor on the circuit where the branch circuits should be powered off? How do we... Right, Yummy Fudge says unless they don't. Unless they don't, yep. And he says some will go into islanding mode. Island mode. Okay, so how do we solve for the grounding conductor on the circuit where the branch circuits should be powered off? I'm not sure what you mean by if the branch circuits should be powered off. The equipment grounding conductor. Are you talking about the equipment grounding conductor? The equipment grounding conductor is Article 250, and the sizing of the equipment grounding conductor is based on the overcurrent protective device. So all of your equipment grounding conductors are sized on the, I believe, I'm almost positive, in 250 on the overcurrent protective device, and I'm looking for anybody out there who disagrees. Size of alternating current grounding electrode, that's the grounding electrode conductor, equipment grounding conductor, the EGC. Some circuits, he says, some circuits will have power. Say a microwave turns on, powered by the inverter via the battery. Okay. There's still a circuit breaker there. And that's fine. That's perfectly fine. And it says, you have to have termination always. Use 90 column. Yep. Microwave will pull power on the grounded back to the source. The grounded conductor. Yeah, because you're powering it from hot to neutral. Okay. I don't know what the issue is there, Yummy Fudge. So far you are absolutely correct. Are you talking you said the grounding conductor? That's the equipment grounding conductor. Or are you meaning sizing of the grounded conductor? Yes, but follow. Whoa. Just lost my 1 second. All right. Yes, but follow this current path of the power on the grounded conductor. Where does it go? Nobody knows. It will stay in the grounded. It's the neutral, so that will go all the ways back up between the hot and neutral. So I'm trying to think. Yummy Fudge. Okay, hold on. Source is the inverter. Yep, source is the inverter. Oh, no grounded. So it's not grounded. So you're saying that the supply from the inverter is not a separately derived system. Well, if it's not a separately derived system, you're still good because you would be interconnected with the service equipment where the bonding is done. That neutral, okay. So I'm not sure if I can draw this or not. And that is for it goes back to the source, right? David Engelhardt says it goes back to the source and then put potential on all the circuits that are supposed to be powered off. He's saying it should be grounded and bonded to the electrode conductor, but it is. So here's my thought. Yum Fudge. All right, so if I have an inverter, and let's say I have my solar panels coming into this, my strings, right? And I have a main breaker here, and then I do this. I'm going to assume this is coming in on the load side of the service disconnecting means. I'm going to make that assumption. And you're saying I have this go out to say, oh, a microwave. Microwave. Right? So, and I have a hot and a neutral. Remember, I have my ground bar and I have my neutral bar. And if you recall, these are going to be connected together. And this is going to there. And then I have out of here, I go down to my ground. This is my grounding electrode. This is my grounding electrode conductor. That's my grounded bar. This is my grounding bar. And I would have a hot, and then I would also come out of this equipment like this. I'd come out of, I come out of this equipment and I would go to the ground, and then I would have a hot and the neutral. The neutral, I'm going to draw a white. The neutral would come back and come up to this bar right there, right? So if I have, so this is my neutral, this is my hot. My hot goes to the circuit breaker. My neutral goes to that bar, which takes it back down to ground. So if I lose my utility, I still maintain the integrity of bonding the neutral to the ground back to the inverter. Even if I have no ground here, I still have a ground there reference that neutral is tied to. And even if I had a sub panel, so if I had, let's say I had a main panel here, and I have my main breaker, and let's say I come out with a feeder, and I feed a sub panel, right? And I believe you would be saying this, right? So this would be your inverter. Okay. I'm looking at what your comments. No, the microwave is on a separate panel. So, all right, let's do this. This is my microwave. Right? Now, when the so I have a ground bar here, and I have a neutral bar here, and the neutral bar is insulated. I would be over here for my ground bar, and let's say I have a neutral bar here. Come off of that, I go to ground. I bond those two together. I bond that to the enclosure, and my microwave, I come back with a ground. It grounds there, and I would come off of here, and I would go with this, and I would there, and I would come with a neutral, right? I would pull my neutral and land there, and then I come off of here with my neutral. I land it to there. So my neutral current still flows back up through here, back up through there, and then back down to ground. So I still have a ground reference. Now, it's not going back to the neutral. It's not going back to the inverter. But I have a return path. Um, no, you feed the inverter. Yeah, but it's all connected. The sub panel is off the inverter. Yep, I think I drew that. Grounded conductor. Got that. The sub panel comes off the inverter. So, oh, what's Robert say? GEC, ground electrical. Yep. So, what I'm not showing here is this. You would have a hot and a neutral, right? So the neutral has to land there. And because all of that neutral is all bonded back to that location, I think, well, yeah, I mean you're grounded and you're grounded. The inverter is grounded. The neutral is grounded through the service panel board because that neutral is the grounded conductor, and it's grounded at one point in the service equipment, which is required by code. You can't bond those anywhere else in the system. They're all insulated from each other outside of that one connection at the service panel. So Yummy Fudge, I think that's how I would approach that. But his diagram is still wrong. Yummy Fudge, no such thing as a sub panel as a feeder panel. Yeah. So what would be wrong with my diagram? I have my neutrals all connected together. I have my ground. My bonding is all connected. Oh, and also I'm missing a bond. I don't know if this is what you mean. I'm missing this bond here. So I have to bond my inverter with the system. So the system is bonded. My neutral, are you saying you don't come out with a neutral? Is it just two hots? Is that what you're saying? Oh, I got balloons. Are you saying that I only have two? And you said the microwave panel is coming off the inverter. Right. Oh, so you're saying you're still powering the panel from the service equipment, correct? You still have this going on, right? You still power from utility, right? You're still powering the sub panel, that feeder panel, from the utility. And if you power that with a feeder, you have to bring the equipment grounding conductor and a neutral. Maybe two hots and a neutral, right? So I might have two hots and maybe have two circuit breakers, but no, it's powered directly from the inverter. Oh, okay. Okay. So then you have a standalone system. You have a panel. When you mentioned if the utility goes away, I thought you meant, so you have a panel and you have an inverter. So there's no utility in the picture, right? And this is your microwave. You still have to have this. This would, okay, so now you're saying it's not a separately derived system. So you've got to go to, I gotcha. Oh, the diagram you sent me via email. And you know what, Yummy Fudge? Oh, man. I see what you're saying. Okay, so it's a standalone system. So then if it's a standalone system, I would have to, I believe we have a section in the code that deals with standalone systems, which is 710. Because now you're basically on an island. You don't have a utility service where you do all your bonding and grounding. You don't have a separately derived system, apparently, because you're saying that the inverter is not a separately derived system. And I'm missing task group 3, code panel 2, task group 3. In standalone systems, they have to be listed, they have to be evaluated. Power production sources, circuit conductors between standalone sources and structure disconnecting means shall be sized based upon the sum. That's it. Well, Yummy Fudge, our next call is going to be on your system, and we're going to talk about standalone systems. Not standalone. You know what? Yummy, maybe next time we'll do this forum right here, and I will get you and me on at the same time, and we can have the discussion. What do you think? You game? Let me know if you're game for that. Otherwise, I will take a look at that. Main is power and connected to the grid. Main panel connects to the inverter. Well, that's the first thing I drew. So if you have the main and it's powered from the grid, that means it's service equipment. That means you have the bonding and everything right there, and your neutral is tied to the ground. Your grounding electrode and your grounding electrode conductor. All right. We're game on. We're going to have fun next time. I got to look at my Tuesday. Next Tuesday, I think I'm going to be at the Western section next Tuesday. I'll see if we can't do a session like this live on Tuesday. We'll talk. All right, Yummy, we'll do that. We'll get some time together. All right, everybody. Look, I loved chatting. I loved this. This was awesome, and I appreciate everybody's dialogue. So I'm going to have to run because there is a Laurel in Omaha. Are you going to be? Hopefully, Laurel, I'll see you at the Western section. Ryan Jackson's a smart dude. He sure is. Yep. All right, everybody. Listen, I am going to hop on the Code Panel 2 Task Group 3 call, which I'm supposed to be on, and we'll take it from there. Thank you, everybody. Thanks for what you do for the electrical industry. Thanks for what you do for electrical safety. Remember to stay safe, and please stay healthy. See you soon.